Reusable calculus. Okay, so we are really doing work in reusable calculus. Reusable calculus means I have ready-made calculus solution. Can I reuse it at other place? This is typically falls in reusable calculus. If I have ready-made solution, if I have ready-made solution in the calculus arena, can I reuse it? What is ready-made solution? One example that we are repetitively repeating is the 1 by x. Consider I have ready-made solution of 1 by x. Means I have something like summation. Ready-made solution means there is a discrete function called 1 by x, not the continuous. There are two big things in algebra. One is called discrete function and one is called continuous function. Discrete function is different, continuous function is different. Discrete function has independent components only at few points, not everywhere. Like I can imagine one series that is sigma. Sigma. Sigma means summation. Sigma x equal to 1 to m. Sigma x equal to 1 to m, 1 by x, fx, 1 by x. This will come as 1 by 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5 up to 1 by m. Okay, I was seeing the solution in the book here and there, and solution is natural log of m plus some constant. I believe it is 0.57 or 0.59 something. Take it 0.57 plus 0.57. Okay, this is the summation of 1 by 1, 1 by 2, 1 by 3 up to 1 by n. Okay, this is what is the function called 1 by x. If I take 1 by x, now if I take this series 1 by 1, 1 by 2, 1 by 3, 1 by 4, in this series there are two things. One thing is the position number. Position number in the series. Position number is 1, 2, 3, 4, 5, 6, 7, 8. At position number 1, we have 1 by 1. Position number 2, I have 1 by 2. Position number 3, I have 1 by 3. Position number x, I have 1 by x. And position number n, I have 1 by n. Okay. Now, if I see there are two things. One is position number, that is the x. Position number, that is the x. Okay, thank you very much. At every position, we have a value called function over x. Position number x, the function over x, that is the value at that position, is 1 by x. Position number n, the value at that is 1 by n. Position number m, value is 1 by m. The last is m, not n. 1 by m. Position number 4, value is 1 by 4. Position number and its value, x and function over x. Sigma x equal to 1 to m function over x. This is what I want. Okay, now to have it, we need to have a continuous function. This is called discrete function. Fx equal to 1 by x. That is true, but it is valid only for x equal to 1, 2, 3, 4, 5, 6. Not x equal to 0.5, 1.6, not in fraction. Only as a whole number, this is valid. Okay, thank you very much. If that is the case, then what will be the summation? To find the summation, if I need to, if someone is able to calculate the summation, this is what written in the book. Through algebra, we can find this solution 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up to 1 by m. And in the book, I am seeing it is ln of m, natural log of m plus 0.57. If I take m as 3, then how much it will be? 3 means 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. Let's take m as 4. Up to 1 by 4, how much it will be? 1 plus half. 1 by 4.2, 1.75 plus 0.33. That will come as 2.08, I think so. 2.08, 2.0809. This is what it will come. 2.09. If I use the bookish formula, that is the summation has been found through the algebraic way, then it will be ln 4. ln 4 I was seeing now. Just before that I was seeing that ln 4 is 1.4. So it will come as 1.4 plus 0.57, 1.97. Expectation is 2.8, 2.9. So zero point 0.1 is less. Let's see our, okay, anyway, I'm going to calculate now. Let's proceed. What we are doing. We have already done in the past. So what we are doing now to have this, to calculate the log, to calculate the summation of 1 by x, we convert 1 by x into continuous function. 1 by x is a discrete function and we convert into continuous function, claiming that if I take x-axis, if this is x-axis at any point x, I have function over x that is the vertical, that is 1 by x. Can I imagine one area from x to x plus 1? One area strip that will go and hit a continuous function called gx. If I have x-axis, if I have x-axis and y-axis, consider a continuous function gx. And on x-axis, I take a point x and x plus 1. And I draw an area strip. Then I draw one area strip. Area strip goes up and hit the gx. The area with the gx is gx dx, x equal to x plus 1. Can I make it equal to fx at x equal to x? 1 by x equal to x plus 1 gx dx. Can I imagine one gx function where gx dx is x to x plus 1? Okay, this is the basic calculus we are using. Means if I am, this concept is to find gx. If I am able to find the gx, then net summation, that is sigma x equal to 1 to m fx, then that will become sig integration limit sign, integration limit x equal to 1 to m plus 1. If I have value m, that is the end, then there fx is 1 by m, and there I have area strip m to m plus 1 with gx. Means net summation is x equal to 1, lowest limit, highest m plus 1 gx dx. It has to be remembered. The net, if I find gx as that is the continuous version of fx, then the net summation, that is sigma m equal to 1 to x fx, will be limit x equal to 1 to m plus 1 gx dx. Thank you very much. What is your gx? To find gx, we will say fx equal to fx at x equal to limit x equal to x plus 1 gx dx. If I say gx dx equal to fx, then I will start gx as dfx by dx minus 1 by x square. 1 by x, differentiation is minus 1 by x square. Minus 1 by x square dx, it will come as 1 by x. Limit x to x plus 1. It will come as 1 by 1 plus x minus 1 by x. If I settle it, it will become minus 1 by x into 1 plus x. If I say 1 plus x is also x, then it is, just leave it. It is minus 1 by x into 1 plus x minus, okay, we want 1 by x. We want 1 by x, but we are getting minus 1 by x into x plus 1. So we will say that we will multiply it by minus x plus 1 to get the same thing. This is successive approximation. We have to reach till 1 by x. When I have a gx dx x to x plus 1, I started gx with minus 1 by x square and landed up in the result as minus 1 by x into x plus 1, where minus 1 by x plus 1 is extra from what we want. So we will try multiplying with minus 1 into x plus 1. People would say you can go other way also. What you got was 1 by 1 plus x minus 1 by x. Yes, 1 by 1 plus x minus 1 by x. Where wanted is 1 by x. So here I can add with 1 by 2 by x, whatever I have got. Let's add it with or multiply it with my multiply up. Okay, whatever we have got, just add with 2 by x minus 1 by 1 plus x. add 2 by x, my whatever we have got. Now plus 2 by x will become 1 by x, minus 1 by 1 plus x, it will take it out. Now what we had started with minus 1 by x square plus 2 by x minus 1 by 1 plus x. I have to start with that. That is the one way. Any people can try. Other way is, if I settle down 1 by 1 plus x minus 1 by x, I get minus 1 by x into 1 plus x. Where needed is 1 by x, means I have to multiply with minus 1 plus x. Let's multiply with minus 1 plus x. This is what we have tried. So we started with minus 1 by x square. Minus 1 by x square. Now with that I will multiply with minus 1 plus x, minus minus plus 1 plus x by x square. That will become 1 by x square plus 1 by x. Now we have new gx as 1 by x plus 1 by x square. 1 by x plus 1 by x square. If I try so, 1 by x will become ln x, natural log of x to x plus 1. That will become natural log of 1 plus x by x, natural log of 1 plus 1 by x, bracket close. And then integration of 1 by x square will be minus 1 by x to x plus 1. That will be minus 1 by x plus 1 minus 1 by x. And that will become plus 1 by x into 1 plus x. If I take 1 plus x for simplicity at x only, then it will become plus 1 by x square. 1 by x square. Anyway, what is ln 1 plus 1 by x? Ln 1 plus x is x minus x 1 by x minus 1 by x square into 1 by 2 and so on. If I take first two picture, if I take first two figure, not the beyond that, then it will come as 1 by x minus 1 by 2x square and then plus 1 by x square. Then it will come as 1 by x plus 1 by 2x square. This is the result. Okay, if this is the result, then we want 1 by x, but we are getting 1 by x plus 1 by 2x square. So I have to subtract with 1 by 2x, 1 by 2x square. Anyway, now we had started gx, previous was 1 by x plus 1 by x square. Now I have to subtract with minus 1 by 2x square. Then it will come as 1 by x plus 1 by 2x square. This is the gx that we have to try again. 1 by x integration is ln x, ln x, ln x, x to x plus 1. That will become 1 by x minus 1 by 2x square plus 1 by 2 into 1 by x square. 1 by x square will settle down as plus 1 by x square only. 1 by x square will be settled down. 1 by x square integration is minus 1 by x. It will be settled down as 1 by x square. Now we have minus 1 by 2x square plus 1 by 2x square. They cancel each other and only 1 by x will remain. This is what we want. Means more or less by staggering or by lemming, we have found gxy, and that is 1 by x plus 1 by x square. 1 by x plus 1 by x, 1 by 2x square. Now to have the final summation, limit is 1 to m plus 1. ln x, ln x minus 1 by 2 into 1 by x, that is the integration, x to x plus 1. ln x, sorry, 1 to m plus 1. ln 1 plus 1, 1 plus m minus ln 1. ln 1 gone, 0. ln 1 plus m, ln 1 plus m. And then beyond that, it will come as minus 1 by 2 into 1 by x. 1 by x is 1 by m plus 1 minus 1 by 1. That will go and become minus m by m plus 1. Minus is waiting outside. Minus 1 by 2 is waiting side. So m minus minus plus, it will become m by 2 1 plus m. Let's first celebrate this solution now. We have got for the series 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 up to 1 by m. The summation is coming in ln 1 plus m plus m by 2 1 plus m. If I take, this is through integral calculus, through successive approximation. If I go with the bookish rule, what is prescribed in the bookish, what medicine is prescribed in bookish is ln m, ln of m plus some harmonic constant, that is 0.57. How much it will come? Ln of m, if I say m is 1, then 1 by 1, answer should be 1. But here ln of 1 is 0. 0.57 is the answer. Okay, but in ours, it will say ln of 2, that is zero point 0.7, plus 1, m is 1, 1 by 2 into 2, 1 by 4, 0.25. 0.7 plus 0.25 is 0.95, very near. Though we have taken many assumptions. At the beginning only we had said we can go with gxy if I had taken as minus 1 by y square, integration came as 1 by y. 1 minus 1 by x square, integration had come as 1 by x. X to x plus 1 means 1 by x plus 1 minus 1 by x, and that will go as minus 1, that will go as 1 by 1 plus x minus 1 by x. We want we want we want minus, we want 1 by x, but we are getting 1 by 1 plus x minus 1 by x. So whatever gx I had taken, I have to add there 2 by x minus 1 by 1 plus x. Then it will nullify, and then we will try again. Minus 1 by x square plus 2 by x minus 1 by 1 plus x. For that I have to try. If we try, then it will become 1 by x plus 2 ln x minus ln 1 plus x. Integration of 1 by x, 1 plus x is minus ln 1 plus x. We have 2 ln x. 2 ln x means ln x square. 2 ln x is ln x square. Ln x square minus 1 plus x means ln x square by 1 plus x. This is what we I'm able to see what it will come. And this side 1 by x. Someone can break this logarithmic or log of x square minus 1 plus x and then see what is nearest we are getting. Okay, this is how it is, and then see math. But whatever the the what path we took, through which we are getting solution as ln 1 plus m plus m by 2m plus 1. Let's try m equal to 2 from the bookish way. Bookish way is saying for m equal to 2, it will be ln 2, that is 0.7. 0.7 plus 0.57, that will come as 1.27. Whereas the answer is 1 plus 1 by 5, that is 2, that is 1.5. Through our way, it is ln 1 plus m, ln 1 plus 2, that is ln 3. ln 3 I was checking, it is 3, it is 1.1. ln 3 is 1.1. 1.1 plus m equal to 2. 2 by 2 into 3. 2 to gone 1 by 3. 0.34. 1.1 plus 0.34 will come as 1.43. 1.43 is better than bookish way, that is I believe 1.27 we had got. This is far better. Someone can comment on this. Okay, somewhere that there is a better solution here for this series. If I take m as 3, then through bookish way it is ln 3. ln of 3 I was checking. ln of 3. ln of 3 is ln, yeah, this is what ln of 3 is 1.1. Through bookish way 1.1 plus 0.57, that will come as 1.67. 1.67. The actual result is 1 plus 0.5 plus 0.33. 1.83, but they are nearing. Now they are minimizing the gap. Means their solution, the bookish solution, is for higher value of m. So they are getting in through that way is 1.67, but actual result is 1.83 or 1.84. What we are getting ln 1 plus m, ln of 4. ln of 4 I was checking, it is 1.4. 1.4 plus 4 by 2 into 5. 2 by 5. 2 by 5. 2 by 5 will come as 0.4. So 1.1 plus 1.4 plus 0.4, 0.8. Our solution is 0.8, expected is 1.83 or 1.84. Our is 1.8, but bookie's way is 1.67. Let's take m equal to 5. ln of 5 is 1.6. I was checking 1.6. 1.6 plus 0.57, that will come as 2.17. 2.17. Yes, 2.17 is the bookie's solution. 2.17. What is required? We have already calculated for m equal to 3, that is 1.83 plus 1.1 by 4, 0.25, 0.25. So that will come at 2.08, 2.08 and 2.08. If 2.08, if m equal to 4, okay, they are getting 1.97. So that is gap. And for our solution, ln 1 plus m, ln of 5 is 1.6. I was saying 1.6. So 1.6 plus plus 5, m is 4, m by 2 by into 6, 2 by 6, 1 by 3, 0.33, 1.33. Yeah, I think so. Hope that much only, 0.33. We'll try again. M is 4. 4 by 2 into 5. That will come as 2 by 5. 0.2 by 5. 0.4. 0.4. That's what I was saying. 0.4. And ln of 5 is 1.6. 1.6. 1.6 plus 0.4. 2. We are getting 2. We are getting 2, and actual answer is, I believe, 2.7. But bookie's answer is 1.9, something like that. So this is everywhere our solution is better. We will take, if I take n equal to 6, then n equal to 6. With our solution, it will come at ln of 7. ln of 7 is 1.94. This is what I was checking. Let's take n equal to 5 and we will close them. N equal to 5. If I take n equal to 5, ln of 6 through our solution, ln of 6 is 1.8. 1.8. 1.8 plus 6 by 2 into 7. 3 by 7. 3 by 7. That will come at around 0.45. So 1.8 plus 0.45 will come at 2.25. Thank you very much. So 2.25 is the answer. For m equal to 5, book is 2.25. Book is way in ln 5. That is 1 point. ln 5 is 1.6. 1.6. 1.6 plus 0.5. That will come as 0.57. That will come as 1.17. 2.17. 2.17. Our solution is 2.25. 2.25, something like that. 2.25, 2.17. What is the actual answer? Okay, up to 4 we have calculated, and that came as, I believe, 2.08. Up 5 is 0.2. 2.28. 2.28 is the solution, whereas our solution is 2.23, I think so. 2.23. Bookie's solution is 2.17. So our is always close. Then I was watching for m equal to 10 also. When m equal to 10, our solution is exactly same, more or less. Whereas bookie solution someone can calculate. This looks like that it is always better. This is an invention anyway. This is not the concept of the discussion, but this is mind-blowing, sensational we are seeing through the successive approximation that we are calculating. Anyway, what is the main concept of this discussion? Consider I have multivariable case. So multivariable case means summation. Multivariable case means summation. Multivariable case means consider a summation x equal to 1. Consider summation x equal to 1 to m. Summation sigma y equal to 1 to n. Summation z equal to 1 to o. There are 3 sigma. and then f x y z function f in bracket x comma y comma z bracket close. What is f x y z? That is y plus z by x. Y plus z by x means I have now I have a three-dimensional matrix. One is 2D matrix which has a row and column. Now we have depth also because z axis is also there. In that manner, we have x is going from 1 to m, y is going 1 to n, and z is going 1 to o. And then I want for each point in the 3D matrix. 3D matrix has each point in x comma y comma z. Each point in x comma y comma z. Okay, where fxyz is x plus z plus y by x means z plus y by x, z plus y by x, z plus y by x plus z plus y by x. There are m into n into o terms are there. The last one is z plus y by x where z is o, y is n and x is m where first is 1 plus 1 by 1. Can we add it? Now we have a discrete function as z plus y by x for which I have to find gxyz continuous function. For that I have to go with successive approximation the way did in the logarithmic series and I mean 1 by x series and that was very difficult. For 3D it will be extremely difficult. I have to start with someone can start fxy is z plus y by x equal to gxy dx dy dx. Okay, means how to find successive approximation gxy is limit x to x plus 1, y to y plus 1, z to z plus 1, gxyz, g as a continuous function, g in bracket x comma y comma z bracket close, dx dy dz. Okay, if that is the case, then gxyz will be d3fxy by dx dy dz. If I differentiate with z first, then it will become z first, then it will become 1 by x, y will go away, then with y is 0. Then we have to start with something, then we will start with something like z plus y by x only. We will calculate the integration, set all the limit and see how much it is. It should be exactly x plus z plus y by x. If it is not that, then we will multiply, divide, subtract and add something and keep changing it till we get the solution. That will be very big. How to make it small? Suppose I know gxyz. This is what the discussion I always pursue. Consider I know gxyz. Then what will be the final solution? Final solution of the summation x equal to 1 to m, y equal to 1 to n, z equal to 1 to o, fxyz will be x equal to 1 to m plus 1, y equal to 1 to n plus 1, z equal to 1 to o plus 1, o plus 1, dxyz, dx, dy, dz. dxyz I can rewrite as c, continuous function in bracket fxyz. Continuous version of fxyz is gxyz. Now I can mention fxyz, z plus y by x. If I start with z first, if I start with z first, then I can divide it as z by x plus y by x. Y by x is constant. I can take it out. C of y by x. C of y by x will go out. Then I can rewrite as C of y by x plus C of z by x. C of yx is a constant that can go outside. I am integrating with dz. Then it will come as integration 1 into dz. Integration of 1 dz is O. Up to 1 to O plus 1, it will be O terms will be there. O. So we are getting O into C of z, C of y by x. Integration of z by x. Z, we are integrating with z. 1 by x is constant because with integration of z, x and y are constant. Integration of z, integration of continuous version of z dz. Continuous version of z, z means 1, 2, 3, 4, 5, 6 up to O. That integration will be O into O plus 1 by 2. Summation of the linear number is O n plus 1 by 2. So O plus 1 by 2. So net solution will appear as O into y by x, c of y by x plus c of 1 by x into O plus 1 by 2. We will proceed now, or we will integrate with the y. If I integrate with the y, the first term is O into c of y by x. 1 by x will go out, and then c of y dy will become n into n plus 1 by 2. It will become O into n plus 1 by 2 into c of 1 by x. Understand? Okay. Next will come as O into O plus 1 by 2, and then 2 into 1 by x, c of 1 by x, integration of dy, just dy, then it will be n, just n. Now final we will integrate with dx. So our answer is like O into n plus 1 by 2, 2, and then integration of c of 1 by x dx. C of 1 by x dx we have already calculated, and that is ln 1 plus m plus m by 2 m plus 1. So net solution will come as O into n plus 1 by 2 into, in bracket, ln 1 plus m plus m by 2 1 plus m by 2 1 plus m, bracket close. This is the first term. Second term where we had started with z by x. So first time it came as O plus 1 by 2. Then after dy it will become n into O plus 1 by 2. Then c of 1 by x dx. Then that will become ln 1 plus m by 2 m plus 1. In both sides this is common. So I can write as ln 1 plus m, bracket close, plus m by 2 m plus 1. In denominator 2m plus 1. 2 into, in bracket, m plus 1. Numerator m into, and in big bracket we have to place what we are doing. O into n plus 1 by 2 plus O into O plus 1 by 2 into n. One is O n plus 1 by 2 plus one is n O plus 1 by 2. This is the result. Someone can try in his spare time. Okay, not available in any of the book. This is called calculus reusability. Wherever I was finding c of 1x, continuous work function of 1 by x, that is dxy, I replaced with whatever I had calculated for 1 by x. Summation x equal to 1 to m 1 by x. That I replaced the solution, ready-made solution. We skipped calculating dxyz, and whatever we did in single variable, we just kept replacing here and there. This is called reusable calculus. None of them are available in the book. Anyone can try successive approximation and reusable calculus. You don't mind supporting us? +91 is the India country code 9483160610 is the telephone number. +91 is the India country code 9483160610 is the telephone number.